G'day COSC 3500 students. I'm going to show you in this video today how to run a code on the getafix cluster using the slurm system. So you've got to keep in mind that on this cluster, you're on a master node, so everyone kind of is on this node that's on the cluster, and then you have to submit a job that goes off to another node, right? Or more simply, another computer that will run the code for you using the resources that you've requested. Okay, so you don't actually run the code on the master node, the one that you're logged into on the main terminal. You don't want to do that. People will get really upset with you, okay, and you'll get in a little bit of trouble. You need to make sure that you're submitting a job into the slurm system so that it goes off onto a node that you've requested. You should compile your code on the master node. That's totally fine. You can do that on the master node. And you can run small scripts on the master node. If you know what nuplot is, you can run a nuplot script, just something that's very, very low, requires not a lot of resources, right? Something like that. But anything that's requiring a lot of resources, you need to submit a slurm job. So the way that I'll demonstrate that right now using the greatest of all scripts, the hello world script. So it's not a lot of resources, so we could technically run this on the master node, but we're going to actually submit a slurm job to see what it is. And we're running this through this Visual Studio Code. Okay, so that we can see and edit the code on the getafix system, and we can also run it. Keep in mind that all the terminal commands that I'll show you guys in a minute, how to run the code and everything like that, they're all the same if you're just SSHing into the getafix via that command prompt or just a terminal on your local machine. Remember, you either have to be on the UQ network, right, or you have to be VPN'd into the network, okay, to actually connect to getafix. So keep that in mind when you're setting all this up. Okay, so I've got this hello world script. You guys can see it's just going to print out hello world, and that's all it's going to do. So we're on the master node, and we're in the correct file. We'll just make sure we've got ls, and we'll compile the code. Even though it's already been compiled, just make sure that it is compiled and there's no errors. Yep, so that's fine. So we've compiled on that master node, okay, and we've got the output executable file up here, right? That out.exe, okay. Now, usually, if you were on your local machine, the way that you would actually run this is you would go ./.exe, right? That's the usual way, and you can see I can run that on the master node. It's not a problem. It's just printing out hello world. But if you guys have programs that are using multiple cores and all that sort of stuff, you don't run them on the master node, as mentioned before. Okay, so that's the output. That's all the program does, which is good. It works. The way to actually run this through the slurm system, so to request resources, is you need to come up with a bash file that essentially states what you want. So before I get into explaining the details of this this goslurm script, this bash file that we need to pass through the slurm queuing system, I just need to make a comment about the properties of this file. So when you first write a bash script just in a text editor and you save it, it doesn't save as a executable. So the computer doesn't actually recognize the file as being able to be run at the terminal. So anytime that we make a new bash script that, say running anything in the terminal, or we're making a new bash script to pass to the slurm queuing system, we have to make sure that we make the bash script executable. Otherwise, it won't run in the terminal. You will get an error. So every time you make a new bash script, doesn't really matter what it's being used for. If you want to run it in the terminal, you have to make it an executable. So to determine whether an actual file can be executed, we can just come down to the terminal and type ls-al So as I mentioned before, the ls function, it just tells you what's in the current directory, like exactly like what we've got up the top here. Right, so we've got these 3 scripts, and you can see these 3 scripts are again here. But this /al flag, it just tells us a bit more information about the files. Okay, so you can see that the user who kind of made the files, right? That was me. This is my username here, right? And what date the files were made on, or what time and date the files were made on. So the important thing that we need to look at here is actually this first column here, right, where there's all this writing and stuff like that, and there's these letters. So essentially what we want to do is make this goslurm script, right, this bash script, we want to make sure that it is an executable file, okay? So we can see that it's not an executable file, and the way that I know that is because I can come down here to this out.exe file, which is an executable file, right? It's that file that we made from compiling the hello world.cpp file, right? And we ran it on the terminal line using that /out.exe command up here, right? And we can see that it's an executable because it's got these X property flags kind of flicked on in its properties, okay? The R and W here, they're just signifying who can read and write, okay? So you can see, right, another example, the hello world.cpp file, it's not an executable file, okay? We can only read and write to it, and you can see that as well because the properties here, there's just R and Ws, there's no X's. So we can't execute that CPP file, which makes sense. The CPP file isn't executable. It's the executable that you generate from the compile line that's executable. So the goslurm script, right, that bash script, it's got the same flags all turned on, right, the read and writes as the CPP file, okay? So what we want to do is actually turn the executable flags on for the goslurm script. So the way that we actually make this goslurm script executable is we just come down to the terminal and we write chmod, chmod, M-O-D, and we do plus, and it's a lowercase x, and then the file name. So this will work on any file, right? It'll make any file that you specify an executable. So the chmod is essentially the change. It's essentially the function that's going to add a property to the file, and this plus x is that property. We're going to add the executable property or functionality to this goslurm script here, this bash script. So once we type that in, we press enter, right? And we can go ls/al again, and we can come down here to the goslurm, and we can actually see, okay, it's had the x added, right, in the same places as that out.exe. So it is an executable file. Now that I've made the goslurm script an executable file, I'll actually go through and explain what's in the file and all of its properties. So all this stuff at the top, it looks like commenting, but it's actually not, okay? So it's similar to how those openmp commands are read in your C code that you'll see later in the semester and understand how all that works. But it's this hash sbatch. So in a bash script, that hash is actually a commented line. But the slurm, when you run that slurm script to actually tell the cluster, okay, this is a job that I want to request a bunch of resources for, you just do this hash sbatch, so that when you actually run this, when you pass this bash script through the slurm queuing system, it knows it comes in here and it reads all this stuff, so it can actually do what it needs to do. So we've just got the job name. I've just got hello world test. You can make that whatever you want. I just want one node, right? And I want just one task. Task per node is 1, right? Some of these will change, especially this one, this CPU per task. Okay, that will change when we're dealing with OpenMP. This stuff will change when we're dealing with that MPI protocol. Okay, so keep that in mind. The amount of memory I want, okay, I've just selected 1 G or 1 gigabyte. Okay, if you wanted megabytes, you could put the megabyte there. instead. And this time here, this is important. Okay, so I've got the way that it's set out, right? Day, hours, minutes. This is very important to set. Okay, so if you're running a parallel program that you actually know it's going to take 7 hours to run, you probably want to tell this program that I want to run it for not 90, maybe I want to run it for 9 hours instead of 7, just to make sure that the program will complete, because this timer here, it will essentially kill the job after a certain period of time once it's started. All right. I've just got a bunch of stuff here that's kind of just echoing, just reading out what's going on. And I've got these two lines here just to be like, yep, I want the OpenMP num thread to be the same as the CPUs per task. Okay, you can't over... if I set this OpenMP num thread, which is the number of essentially threads that I want the program to see to be able to parallelize along, if I set this greater than this CPU per task that Slurm sees, it won't run properly. It's just the Slurm system will be like, you're over requesting stuff. It will most likely run, but it's going to cause a little bit of havoc. Okay, so you want to keep the OpenMP thread the same as the requested resources that you've told Slurm, which is that queuing system again. All of these is just a bunch of echoes just to make sure that everything that we've requested is requested correctly. You don't really need them, but it's just for your own sake, for just checking sanity. This is just a check to make sure that the executable file is actually present. Okay, so that it'll save a little bit of time if it tries to run and there's actually nothing there, right? And then you get down to the line where you actually execute the program and, well, there was no program there to be starting with, so it's a bit silly, okay? So this just lets you know, you have not compiled this code yet, like you need to go and compile it, okay? Again, totally optional. This is the line that actually runs the code, okay? I've got this time here. This is just a bash script command that essentially just says how long the executable file took, right? How long the program took to run. That's the actual file that I'm running, right? That out.exe, okay? And the these angled braces here, right, or these greater than signs, this is just saying dump whatever this output, whatever the program outputs, just put it into this file, this output file.txt, okay? Which most of you probably should be aware of, that you can do those kind of things. So we'll save that file. We'll come back down into the terminal, and the way that we run the program, right? I showed you before on your local machine, or if you're on the master node, you could just run the program ./out.exe, right? And it runs, but we need to run this through the Slurm queuing system. So the way that we do that is we just write sbatch space, and then we just run this script that we've made, okay? This bash script. So this is essentially, it's just going to read through this script, and it will, because all this stuff here is at the start, and you're calling sbatch, it's going through this sbatch, which is this Slurm queuing system for the cluster. It's going to see all of this stuff and be like, okay, these are all the resources that you want. Let me check, let me see whether I can actually give you those resources, or you might have to wait a little bit for people to finish their other jobs, and then your job will jump in and it will start. And then it'll just go straight down into this, right? Once it's been like, yep, you can start your job, you've got all the resources, it will just start doing all these bash commands that are in here, and then after all these commands are run, it'll run the program that we want. Okay, so we go sbatch back down into the terminal. We go sbatch, and then we just do the name of that bash script. So goslurm.sh, and we hit enter. And we can see submitted batch job, right? And we've got this ID here. Now, because this was a relatively small job, it's most likely already been done. Okay, but you might not see any output up in your folder system. All right. So what you need to do is just refresh the folder system. So the way that we do that is we just come up here to the little reload circle up here, right? Refresh Explorer, okay, and we just hit that, and you can see I've got two extra files in here now. I've got an output file.txt, right? That's the thing that I requested that this output program dump any outputs that this program has, right, from this executable. Dump any of the outputs from that program into this file, output file.txt. Okay, so I've got that file, but I also have, just go back to the CPP file. I also have this .out file, this slurm.out file, right? And you can see that this number here, right, that's in the file name, it matches this batch job ID, this job ID number, right? That sbatch outputted. So if I go to that, all right, it's actually outputting everything that the that goslurm script has requested or has done. Okay, so it always outputs a bunch of the stuff that you see when you initially log into the getafix cluster. It always outputs everything again, right? I think there's a way to turn it off, but I'm not 100% sure. But you can see here, right, all the stuff below that, right, all of these things. This is all the things that I wanted that goslurm script to output. So if I split this up, right, you can see these outputs here. This is exactly what I requested to be echoed out. Okay, so it's this slurm with the job ID.out file that will also output everything that's in that actual bash, that goslurm script that we've made. Okay, so you don't have to name it goslurm.sh. You could name it whatever you want. Okay, it just has to be a bash file, that's all. And you can see here I've got some numbers. Those numbers are associated to that time call that I did, right? I did this bash time call on this actual program file, and it's outputted it, right? So it was a hello world script, so it's done it very, very quick, right? Less than a second. But again, if I want to see what this program outputted, I got to go to this output file. Okay, so I come up here and I can see the output file, right? It's just printed hello world, which is exactly what the program was required to do. Okay, so that's how you run the scripts on the cluster. All right, so I'm SSH'd into the getafix cluster. I've got this terminal window. I'm on the master node, but I need to send a job request to request a bunch of resources to submit and run my code on one of the other nodes that are on the cluster. So I compile I compile the code on the master node. Okay, that's totally fine. Don't be sending off slurm scripts to compile code. It doesn't require a lot of resources to compile a code. And you know, if you were on your local machine, you would run this script to actually run the program, right? But we don't want to do that. We don't want to run the script on the master node. We want to submit it to the slurm queuing system to request the resources that we want to run on a different computer or a different node on the cluster. And the way that we do that is we just type this sbatch, and we've made this bash script file, and it essentially runs through here and runs the code. Okay, thanks for watching. That's it.